Welcome to solverfy.
Alright, so for this problem, we are going to be using this balanced chemical equation to find the volume of gaseous products. And for this problem, I'm going to be using R is equal to 62.36 liters torr per mole Kelvin. And they give us that our temperature is 350 degrees Celsius. I'm just going to turn this into Kelvin by adding 273 Kelvin. And this is going to equal 623 Kelvin. Since for our pressure is in torr, and I'm using an R value in torr, I'm just going to leave our pressure alone. And in part A of this problem, we are looking for the volume of our gaseous products in liters. Alright, so according to this balanced equation, we know that for every 2 moles octane or C8H18, that gives us 34 moles of products. Both CO2 and H2O in this equation are gas, and we have 16 moles of CO2 and 18 moles of water. So this means that for every 1 mole of octane, we get 17 moles of products. All right, so for our moles of octane, that's going to equal to our mass of octane that they give us over our molar mass. And they say that we have 100.0 grams, and the molar mass is 114.23 grams per mole. Grams cancel out, so we're left with moles. So we have 0.875 moles of octane. Alright, but remember, for every 1 mole of octane, we have 17 moles of products. So we're going to take this number, which is 0.875 moles, and we're going to times this by 17. When we calculate this out, it's going to be 14.88 moles of our gaseous products. Alright, so when we use our PV is equal to nRT, we know that we're looking for volume. So V is going to equal nRT over our pressure. So if we just set everything up, V is going to equal this number of moles, so 14.88 moles. We're going to use our R value, which is 62.36 liters torr per mole Kelvin. We're going to times that by our temperature, which is 623 Kelvin. And we're going to divide this all by our pressure, which is 735 torr. So when we calculate all of this out, our volume is going to be 786.52 liters of our gas products. Alright, and this is how we solve for part A of this question. Alright, so for part B of this question, it's asking what is the volume of exhaust after all of the O2 has reacted. But in this question, they're asking us to basically neglect nitrogen and argon in the gas or in the air. So for part B, we're going to find how much O2 is necessary for the reaction to take place. So we're going to use our moles of octane, which is 0.875 moles of our octane, And we know from our balanced equation that for every 2 moles octane, we have 25 moles of O2. So we're going to be using that ratio to find the moles of O2. So we're going to take 25 for the moles of oxygen divided by 2 for the moles of our octane, and we're going to times that by our moles of octane, so that way we get the moles of O2. And when we calculate this out, it's going to be 10.94 moles of our O2. And let's find the volume, so that way we know how much air our volume is. So I'm going to be setting up V is equal to nRT over P. So V is going to equal our new moles of O2, which is 10.94 moles. We're going to times that by the same R value, so 62.36 liters torr per mole Kelvin, times it by the same temperature, which is 623 Kelvin, and divide that by the same pressure, which is 735 torr. Alright, so when we calculate this out, our volume of O2 is going to be 578.26 liters of O2. Alright, and it says that our air, which is made up of nitrogen, oxygen, and argon, has 21% of O2 in it. So let's get the actual percentage of air that we're going to need if it was just O2 reacting. So 21% of our O2. This is going to be the volume that we just found of our air, which is 578.62 liters of our O2. And we're going to divide that by 0.21 for our 21%. So our new volume of O2, or air needed, is going to be 2,753.62 liters, and this is of air needed. Alright, so it's asking for our total volume of exhaust. So for our exhaust, this is going to equal our total air minus our O2 that's consumed from the reaction. So this is going to be our 2,753.62 minus the 578.26 liters of air. So this is going to equal 2175.36 liters. And remember, it's asking for the total exhaust, or the total gases in the exhaust. This is just part of it. So to get the total exhaust, we have to take the volume that we just found, so 2175.36 liters, plus, and we're going to go all the way back up here. This is also part of our gas product, so this is also in our exhaust, so we need to add 786.52 to this. Alright, so when we add these two together, our new volume of our total exhaust is 2,961.88 liters. And that is the total exhaust with just O2.